Alright, what's up guys? Welcome back to Stonks Maxxing day 37. This is Intel part 1.5, so I don't have too much time. This is actually my first day at work. I made it to the lobby and I just have to wait. It's 8:20, I think some of the other interns are coming, and then also I have to meet my boss too, and she's coming down at 8:20, so I have like 20 minutes to kill here. I want to be able to go over Intel's strategy roadmap again. So yesterday's stream, I kind of got lost in the sauce with a lot of the technological and chemistry, physical engineering aspects of the foundry business. And looking forward, that's something that I hoped I can understand at some point. And it's going to take, I'd assume, a decent amount of time. Not super smart, so it takes me a while to kind of learn the basics, and then from there, once I build the foundations, I'll be able to build. I remember reading yesterday Shape by Jordan Ellenberg, and there's a quote, I think, by Euclid, the geometry guy. He said that you have to build a foundation of axioms, and then from those axioms you build these propositions, which are like the logical next steps. So hopefully that's what I can do with the semiconductor business and how all of the manufacturing stuff works. Okay, so let's see what we have here with our notes. Just a reminder, there's really 3 strategies that Intel seems to focus on here. I want to say the biggest one is probably its shift from just producing its own chips in its own foundries to outsourcing, not outsourcing, but contracting itself, kind of like how TSMC does their business. So they want to be a contract manufacturer for fabless chip companies like NVIDIA, Qualcomm, AMD. Those are probably the biggest 3. And when we look at the foundry landscape today, you have TSMC, that's Taiwan Semiconductor Manufacturing Corporation. That is the largest semiconductor manufacturing company in the entire world. They're headquartered in Taiwan, and with that, there's a few geopolitical risks involved. I just saw in the news 2-3 days ago on Twitter, China was doing another military practice, I think on the Strait of Taiwan and then around the island. So there's a lot of geopolitics, legislation, export controls between US and China right now, and I hope nothing comes out of it in terms of violence and war. That would be really catastrophic, honestly, not just from an economic point of view, but from kind of this livelihood point of view. And so praying for the best, hoping for the best. There's also Samsung. So Samsung is a South Korean company that is, I'd say, number 2 in terms of revenue in the foundry business. Samsung, TSMC, and then the final one is Semiconductor Manufacturing International Corp, SMIC. This is actually a Chinese state-backed foundry business that currently has a lot of export controls in the United States, from the United States. So it seems like today the US is limiting a lot of exports from businesses like Intel, NVIDIA, ASML, AMD, Qualcomm. All of these companies produce a lot of the leading edge chips and equipment in order to actually build and manufacture semiconductors. US doesn't want the Chinese government and the Chinese economy to be able to have access to these technologies in order to kind of hinder their development and growth, to ensure that the US stays, I guess, on top. Semiconductors are a huge player and are components of the military systems today. You have drones, missiles, computers, cybersecurity, I think. So those are kind of like very broad concepts, but a lot of today's weapon systems all use semiconductors, thousands of integrated circuits. So US doesn't want China to have that capability, and so that's kind of the point that's pictured in Chip War by Chris Miller. his view on kind of the geopolitics right now surrounding the whole semiconductor ecosystem. Now, Intel itself has very small market share in this entire foundry business. The US doesn't have a huge manufacturing capabilities, unlike a lot of the Asian countries in South Korea, Taiwan, Japan, and China. Global Foundries, that's probably the biggest US-based company that operates fabrication plants. This was actually spun out of AMD. AMD is now a fabless chip design company that competes with NVIDIA, Intel, Qualcomm on processors and I want to say logic chips more so than memory. Memory is really dominated by Micron. I want to say Samsung as well, SK Hynix. Those are two South Korean companies that have, I think, the top 1 and 2 market share in terms of revenue for memory chips in the entire world. Okay, so this is kind of the picture that we have in terms of the foundry business. And there's this nice infographic I don't think I have here. I downloaded it yesterday. This is part of one of Intel's conferences in the past, I want to say 4 months ago in February. But this is kind of their roadmap. And what I got caught up upon was the idea of two different things. So there's the development of transistors, and there seems to be kind of evolutions and generations of technology for transistors. From what I understand, transistors at a high level act as switches on an integrated circuit. So the way that today's computers work, everything is pretty much digital. What that means is the way you send signals on a circuit, it's discrete instead of continuous. Discrete in the sense that there's a finite number of values that are passed through the signal. So in the case of digital computers, you have bits. So bits take the form of 0 or 1, and 0 just means that you pass through, 1 means that you don't. Oh, wait, are you Adam, by the way? Are you Adam? Yeah. I'm Brian, one of the interns for... Yeah, nice to meet you. Sorry, I'm just like streaming on YouTube for some random stuff. Yeah, let me end this real quick.